acetylene on reaction with sodium metal, it forms sodium acetylide. Why? Because it is acidic in nature. For all active hydrogens, it reacts with the active metals. Sodium does not react with the ethylene, but it reacts with acetylene. That is, the hydrogen is attached to sp carbon is active just like acid. So here it forms like this: CH triple bond CNA, monosodium acetylide. If I take here 2 moles, both sodium, that is excess sodium is taken, that both hydrogens can be removed. In this case, this can react with methyl iodide. The sodium iodide is eliminated. It forms propine. Propine is still acidic because of hydrogen attached to the sp carbon. This propine on reaction with hydrogen and nickel, this is called Sabatier-Sanderens reaction, or hydrogen and palladium, or hydrogen and platinum. All 5 bonded compounds changes into saturated. That is, unsaturated compounds brought into saturated like the CH3, CH2, CH3. Now this is propane. This propane on chlorination in presence of UV light. This is alkane. So alkane is a saturated hydrocarbon. Its property is free radical substitution. Now there are 2 types of carbons that are available: sp3 carbon with 3 hydrogens, sp3 carbon with 2 hydrogens. These are secondary hydrogens. These are primary hydrogens. Generally, secondary hydrogens are more reactive than primary hydrogens. So there is a competition between these 2 hydrogens. So here it produces CH3, CHCl, CH3. That is isopropyl chloride or 2-chloropropane. Now this isopropyl chloride reacts with the ethyl alcohol and KOH. The function of this ethyl alcohol and KOH is dehydrohalogenation. It is called alcoholic KOH. In place of alcoholic KOH, you can use sodamide also. Sodamide has the same function as that is alcoholic KOH, but sodamide is a relatively powerful dehydrohalogenating agent when compared to alcoholic KOH. So now we get this molecule, that is CH3, CH double bond CH2, that is propene. Now this propene on reaction with HBr in presence of R2O2. This is a alkene with unsymmetrical alkene. This unsymmetrical alkene undergoes addition 2 ways. One is Markovnikov rule, the other one is anti-Markovnikov rule. Markovnikov rule and anti-Markovnikov rule. If R2O2 peroxides or sunlight or UV light is applied, then it undergoes anti-Markovnikov rule. If there is no this case, then it undergoes Markovnikov rule. What is Markovnikov rule? The negative part adds to the less hydrogenated carbon based on the intermediate carbocation stability. So simply, if R2O2 is not there, then Br will be adding here. If R2O2 is there, then reverse. So the major product here it is CH3, CH2, CH2Br. This is N-propyl bromide. Now this N-propyl bromide on reaction with sodium in presence of dry ether. In the previous conversions, I told about this function. Function of sodium in presence of dry ether is Wood's reaction. In Wood's reaction, halogen attached to sp3 carbon is removed and coupled. That means RX becomes RR. Therefore, this becomes N-hexane. N-hexane, that is normal hexane. Now this normal hexane on reaction with B2O5 or molybdenum trioxide or chromium trioxide. This is the property of alkane. N-hexane, when reacts with these catalysts at high temperatures and high pressures, then it undergoes aromatization. This is a special property of hexane in presence of catalyst, aromatization. Aromatization means 6 carbons change into, that is, benzene. that is benzene. Normal hexane changes to benzene. Now, this benzene on reaction to hydrogen and nickel, this is nothing but Sabatier endurance reaction at elevated temperatures. Generally, alkenes and alkynes readily undergo, that is unsaturated hydrocarbons, readily undergo hydrogenation. But benzene does not undergo hydrogenation easily, but it can be done. So on benzene hydrogenation, it produces cyclohexane. Cyclohexane. Now the cyclohexane is nothing but all sp3 carbons. Now, next reaction. This is in presence of Cl2 and UV light. The characteristic property of alkane is substitution. Substitution means removal of hydrogen and replace with other. So any one of the hydrogen is same because all are CH2, 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 CH2. So it will be like this. So Cl, chlorocyclohexane, chlorocyclohexane. This chlorocyclohexane on reaction with the sodamide. Sodamide. The function of sodamide is dehydrohalogenation. Dehydrohalogenation means removal of. So HCl is removed or HCl is removed. It produces this compound. This compound, that is cyclohexene. Cyclohexene. Now this cyclohexene on reaction with KMNO4 in presence of base at 25 degrees centigrade. This is called Bayes reagent. Cold alkaline potassium permanganate. Cold alkaline potassium permanganate. That cold alkaline potassium permanganate is nothing but Bayes reagent. The function of Bayes reagent is nothing but addition of hydroxyl groups on pi bonds. That is, it is also named as hydroxylation. That means the pi bonds are removed and it forms like this. The molecule will be like this. OH and OH. This is called hydroxylation. This compound on reaction with PCl5 or yesterday I told you in the previous video I told you PCl5, PCl3, SOCl2, they are nothing but producing this compound. That is Cl and Cl. Cl and Cl. The function of PCl5, removal of OH. Only when OH is attached to sp3 carbon. Now, this upon heating with the zinc, on heating, the function of zinc is dehalogenation. The function of zinc is dehalogenation. The function of zinc and HCl is reducing agent. If zinc and HCl is placed, cyclohexane is obtained. If only zinc is placed and heated, then it changes into this compound. That is this hexene. You can write here also, but here I have written for the convenience. Cyclohexene. This is called cyclohexene. This is cyclohexene. Cyclohexene on reaction with KMNO4 in acidified medium. On reaction with KMNO4 in acidified medium, the function of the potassium permanganate in acidified medium, if it is alkene, the alkenes get cleaved and changes into carboxylic acid. Whenever acidified potassium permanganate is used for alkenes, that is unsaturated compound, double bond gets, that is cleaved, and the adjacent carbons get oxidized to carboxylic acid. These are unchanged. Here it changes this compound. That is, the compound will be like this: CH2 4 times COOH and COOH. CH2 4 times in between hexane dioic acid. Hexane, here it gets break, that is cleaved. This becomes carboxylic acid. This also becomes carboxylic acid. And now this becomes hexane. Now this compound, in presence of sodium hydroxide and CaO, the function of this sodium hydroxide and CaO is soda lime. The function of soda lime is decarboxylation. Decarboxylation means removal of CO2. Therefore, there we get this compound. CO2 removed, we get this butane. What is that butane? N-butane. N-butane. This N-butane on reaction with N-hydroxyl Cl3 This N-butane on reaction with anhydrous AlCl3. The function of anhydrous AlCl3 is rearrangement. This is the type of reaction. That is out of 5 types, 1 type. Anhydrous AlCl3 causes the rearrangement. So here 4 carbons are there. How they get rearranged? N-butane on reaction with anhydrous AlCl3, it causes a rearrangement. It changes into isobutane. This isobutane is it. Now isobutane on reaction with the KMnO4. This is the property of alkane. Alkanes do not undergo oxidation easily because all are saturated hydrocarbons. So they are not get oxidized by potassium permanganate, provided if there is a presence of tertiary hydrogen that then undergoes oxidation. This is the tertiary hydrogen. These 3 are primary hydrogens. So now tertiary hydrogen changes into like this. Changes into like this. This is called tertiary butyl alcohol. Tertiary butyl alcohol, because this hydrogen is oxidized. Now this tertiary butyl alcohol on heating with H+. This indicates heating with acids. Primary alcohols, secondary alcohols, tertiary alcohols. Tertiary alcohols are easily undergoing dehydration. In case of ethyl alcohol with sulfuric acid at 170, ethylene is formed. In case of tertiary butyl alcohol, even with phosphoric acid, it undergoes formation of alkene. That means mild acid is also sufficient because it is more active. Hence, it changes into like this compound. This is also alkene. Now, this alkene on ozonolysis, that is in presence of water and zinc. There are 2 types of ozonolysis, reductive ozonolysis and oxidative ozonolysis. Here I am using zinc. Whenever I use zinc, it is called reductive ozonolysis, which will not produce acids. If zinc is used, then they produce only aldehydes and ketones. If zinc is not used, corresponding acids will be formed. So if zinc is used, it is called reductive ozonolysis. It cleaves here to form this compound, acetone, and this compound is formaldehyde. Acetone and formaldehyde. So these are the 2 compounds, acetone and formaldehyde. This compound on reaction with zinc amalgam and concentrated HCl. Zinc amalgam and concentrated HCl. Or you can use any reducing it. It produces propane. These are simple conversions.